Welcome to this video on object-oriented programming. In this segment, we will introduce you to the concept of object-oriented programming (OOP). Object-oriented programming is a programming paradigm that is based on the concept of objects. An object is a self-contained entity that contains both data and behavior. In OOP, we create objects that interact with each other to solve a problem. OOP is different from other programming paradigms such as procedural programming, which focuses on the sequence of steps to solve a problem. In OOP, we focus on the objects and their interactions to solve a problem. One of the key benefits of OOP is that it allows us to create reusable code. We can create objects that can be used in different parts of our program, or even in different programs altogether. Another benefit of OOP is that it allows us to model real-world concepts more easily. For example, we can create an object that represents a car with properties such as make, model, and color, and methods such as start and stop. OOP is used in many programming languages, including Java, C++, Python, and Ruby. It is a powerful paradigm that can help you write better, more efficient code. In the next segment, we will discuss the four fundamental concepts of OOP: encapsulation, inheritance, polymorphism, and abstraction. In the previous segment, we introduced you to the concept of object-oriented programming. In this segment, we will discuss the four fundamental concepts of OOP: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation is the concept of hiding the implementation details of an object from the outside world. This means that the object's internal state is not visible to other objects and can only be accessed through its public methods. Encapsulation helps to keep the code organized and maintainable, and also provides security by preventing unauthorized access to an object's internal state. Inheritance is the concept of creating new classes based on existing classes. The new class, called the subclass, inherits all the properties and methods of the existing class, called the superclass. This allows us to reuse code and create more specialized classes. For example, we can create a subclass of a car class called sports car, which inherits all the properties and methods of the car class, but also has additional properties and methods specific to sports cars. Polymorphism is the concept of using a single interface to represent multiple types of objects. This means that we can treat objects of different classes as if they were the same type of object. Polymorphism allows us to write more flexible and reusable code. For example, we can create a method that takes an object of a superclass as a parameter, and then pass in objects of different subclasses to that method. Abstraction is the concept of simplifying complex systems by breaking them down into smaller, more manageable parts. In OOP, we use abstraction to create abstract classes and interfaces. An abstract class is a class that cannot be instantiated, but can be used as a base class for other classes. An interface is a collection of abstract methods that define a contract for how a class should behave. Abstraction helps to reduce complexity and increase maintainability. In the next segment, we will discuss how to implement these concepts in code. In the previous segment, we discussed the four fundamental concepts of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. In this segment, we will discuss how to implement these concepts in code. Encapsulation is implemented in code by using access modifiers such as public, private, and protected. Public methods and properties can be accessed from outside the class, while private methods and properties can only be accessed from within the class. Protected methods and properties can be accessed from within the class and its subclasses. Inheritance is implemented in code by using the extends keyword in Java and the symbol in Ruby. When a subclass extends a superclass, it inherits all the properties and methods of the superclass. The subclass can then add its own properties and methods, or override the properties and methods of the superclass. Polymorphism is implemented in code by using inheritance and interfaces. When a subclass implements an interface, it must provide an implementation for all the methods defined in the interface. This allows us to treat objects of different classes as if they were the same type of object, as long as they implement the same interface. Abstraction is implemented in code by using abstract classes and interfaces. An abstract class is a class that cannot be instantiated, but can be used as a base class for other classes. An interface is a collection of abstract methods that define a contract for how a class should behave. By using abstract classes and interfaces, we can create a simplified, high-level view of a complex system. In summary, object-oriented programming is implemented in code by using access modifiers, inheritance, interfaces, and abstract classes. By using these concepts, we can create reusable, maintainable, and flexible code. In the next segment, we will discuss some best practices for object-oriented programming. In the previous segment, we discussed how to implement the four fundamental concepts of object-oriented programming in code. In this segment, we will discuss some best practices for object-oriented programming. 1. Keep your classes small and focused. A class should have a single responsibility and should not be responsible for too many things. This makes the code easier to understand and maintain. 2. Use meaningful names. Use names that accurately describe the purpose of your classes, methods, and variables. This makes the code easier to read and understand. 3. Avoid global variables. Global variables can make the code harder to understand and maintain. Instead, use local variables and pass them as parameters to methods. 4. Use inheritance and interfaces wisely. Inheritance and interfaces can be powerful tools, but they can also make the code more complex. Use them only when they are necessary, and keep them simple. 5. Write unit tests. Unit tests are a great way to ensure that your code is working as expected. They also make it easier to refactor your code without introducing bugs. 6. Keep your code DIY. DIY stands for Don't Repeat Yourself. This means that you should avoid duplicating code and instead use functions, methods, and classes to encapsulate common functionality. 7. Use comments sparingly. Comments can be helpful, but they can also make the code harder to read. Use comments only when necessary and make sure they are clear and concise. By following these best practices, you can write better, more maintainable object-oriented code. In the final segment, we will summarize what we have learned about object-oriented programming. In this video, we introduced you to the concept of object-oriented programming OOP. We discussed the 4 fundamental concepts of OOP: encapsulation, inheritance, polymorphism, and abstraction. We also discussed how to implement these concepts in code, and some best practices for object-oriented programming. To summarize, object-oriented programming is a powerful programming paradigm that allows us to create reusable, maintainable, and flexible code. By using encapsulation, inheritance, polymorphism, and abstraction, we can create objects that interact with each other to solve a problem. We can also model real-world concepts more easily and create code that is easier to understand and maintain. Some best practices for object-oriented programming include keeping your classes small and focused, using meaningful names, avoiding global variables, using inheritance and interfaces wisely, writing unit tests, keeping your code DIY, and using comments sparingly. We hope that this video has given you a good introduction to object-oriented programming, and that you are now ready to start writing your own object-oriented code.